Hi everybody, today we're going to look at data tables and frequency distributions. When looking at a large number of data points, it's often useful to organize the data into a chart, a table, or a graph. But to start, we're going to look at a frequency distribution which organizes the data points and the frequency with which they occur. As an example, a class was surveyed to find out how many classes each student is taking this semester. The results are listed below. What you can see is we have a lot of data points with the numbers 1, 2, 3, 4 kind of scattered all around. It's hard to get a good picture of how many classes each student was taking. So what we can do is rewrite this data in a table. When we make a data table, we often call it a frequency distribution. The table or frequency distribution is composed of rows and columns. The first column represents the category that we're looking at. So in this example, we're looking at the number of classes a student was taking, and our results were 1, 2, 3, and 4. Then the second column tells us how often each of those categories occurred. So we had 11 students taking one class, 8 students taking 2 classes, 7 students taking 3 classes, and then 4 students taking 4 classes. It's important to always label the columns in your frequency table or frequency distribution. That way the reader knows exactly what the data represents. An end-of-year HR review revealed the number of sick days taken by employees. In our frequency distribution, we can see that we don't know how many people took 0 days off. We know that 42 people took 1 to 2 days off, 25 people took 3 to 5 days off, and then 7 people took 6 or more days off. We have a total of 100 employees, which will help us find how many people didn't take any sick days off. What we need to do is look at the 42, 25, and 7 and subtract that from 100. We have 100 minus 42 minus 25 minus 7 is 26, which says 26 employees didn't take any sick days. Our second type of table is called a relative frequency distribution. A relative frequency distribution finds the percent of the sample that each data point represents. To find the relative frequency distribution, we divide the frequency of the particular category by the total number in the distribution, and then we write that number as a percentage. If we go back to our previous example about the number of classes taken by students, the first thing we need to do is find our total number of students, which is 30. Then we look at the number of students who took one class, which is 11. We divide 11 by 30, which gives us 36.7%. Then our 8 students that took 2 classes becomes 8 over 30, which is 26.7%. The 7 people that took 3 classes is 7 over 30, which is 23.3%. And then our 4 people that took 4 classes is 4 over 30, which is 13.3%. When we're looking at a relative frequency distribution, it's important that our total number adds up to 100%. That way we know we've represented everything or everyone in the distribution. As data gets larger, it becomes harder to work with. So when we have a large number of data outcomes, we often group the data into classes. There are a couple common rules for grouping data. Generally, we like 5 to 12 data classes, but a lot of that depends on the type of data we have. Every data point can only belong to one of those data classes. All data classes should have the same width, and none of them should overlap. Let's look at an example. Let's say we have the weights of football players, and you can see they go everywhere from 175 up to 338. Just coming up with a frequency distribution would not be very helpful because we would have too many different data points. So what we're going to do is come up with groups. I decided to group them this way. I went 175 to 195, 196 to 216, 217, 237, etc. Once I did that, I could go back and count how many of the players fall within each range. So I found out there were 11 players that weighed from 175 to 195, 18 in the category 196 to 216, 21 in the category 217 to 237, 9 that were between 238 and 258, 6 were between 259 and 279, another 6 from 280 to 300, 11 in the 301 to 320 category, and then 4 in the 321 to 341 range. Again, we could go back and make this a relative frequency distribution. The first thing I need to know is the number of football players. Adding up the frequencies, I have a total of 86. So to come up with my relative frequency, I divided each frequency by 86. Let's look at one more example. A streaming service introduced a new plan to customers. All customers were given the option to keep their current plan, switch to the upgraded plan, or cancel their service. Let's use the information to find the percent of customers that canceled the service. From our chart, we can see that 50% renewed the current plan, 15% decided to upgrade to the new plan. What we don't know is the percent of customers who canceled. To find the missing percent, we'll take 100% minus 50% minus 15%, which is 35% decided to cancel. As we continue to talk about frequency and relative frequency, we'll move on to some graphs to give a nice visual to the data.